Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Nathan Mervold, and like Avi, Nathan was not able to be here in person, so we recorded some footage and did a little bit of editing to produce the video that you're about to see. So Nathan Mervold is currently the CEO of Intellectual Ventures, which he co-founded in 2000. Prior to Intellectual Ventures, he worked at Microsoft for 13 years, during which time he founded Microsoft Research, and he'll be telling that story. So let's see, here is Nathan.
In 1990, I started scheming as to how Microsoft could have a research lab. Now, at the time, that was kind of a crazy proposition. No Silicon Valley company had a research lab, even though all of Silicon Valley sort of came from Xerox PARC, which was a research lab. And the contradiction was sort of explained in a book called Fumbling the Future, which sort of explained to everyone, oh, Xerox shouldn't have done this research lab, even though that's what gave rise to personal computers and everything else. So it was kind of a strange environment to be asking for a research lab, but I persevered and I wrote a big memo on it, and I convinced Bill and then everybody else, and so we were in business to have a research lab, only we needed somebody to run it. So I'd met Gordon Bell, and Gordon was both a guy who had had a great history in research, and he just might be crazy enough to help out on this. Well, the second part was certainly true. He was crazy enough, and he helped. So Gordon and I went on this pilgrimage around the country, meeting with some of the great names of computer science to see could we convince them to come to Microsoft and run research. And it was interesting because a lot of people that were very famous, that I had read their papers, I knew all about them. And we'd come in, and Gordon and I would walk out, and we'd be like shaking our heads like, oh my God, no way, no how. Sometimes they would tell us up front that they weren't interested. Of course, that was presupposing we were interested. We were interested in talking to them. So finally, we decided to go see Rick Rashid at CMU. And he was maybe halfway through the whole process. Not all the way at the end, but halfway through. So Pittsburgh isn't really on the way to anywhere except Pittsburgh. So we go to Pittsburgh, and we meet with Rick. And Rick was fantastic. He was funny. He was had a great research track record. He had a property that actually I would find he kept all, for years and years and years at Microsoft also, where he could talk about very high-level computer science things, but he also would tell you how many instructions a loop took, because he knew, because he actually wrote the code. Now, I actually wrote code, so I thought that was kind of cool. A lot of these other people had sort of gone on to what they viewed as a higher plane of existence, where they could be a head of a department or a dean or even a big researcher in a big research lab, and not have to do petty little things like writing code. Well, that always annoyed me, because we wrote code for a living at Microsoft, and if you don't love writing the code, how are you going to actually do anything else? Well, Rick clearly loved writing code, but he also still could be an academic of the first water, as opposed to many of these guys who thought that being a great academic and being a great researcher or a great research administrator meant that they should never get their hands dirty. So Gordon and I walk out of the of meeting with Rick, and we're like, yes, this is the guy. Now, Rick was sort of polite to us and was a little bemused with the whole thing. Of course, if you know Rick, you know that that's often the way Rick seems, a little bemused with the whole thing, because I think Rick is bemused with pretty much everything. But he had not set our expectations pretty low. Nevertheless, Gordon and I were high-fiving it all the way out to the car. We drove like lunatics to get to the Pittsburgh airport so we wouldn't have to spend the night there. And the whole way back, we're thinking, this is great. This is great. We found the guy. We're going to talk to a couple of the guys, but we found the guy. So we make a formal offer to Rick, and he turns us down. So I call him up, and I say, surely I can talk him out of this. He turns me down again. I was at a bookstore. Actually, back in the early 90s, we had these things called bookstores. And I remember I bought this book. I still have it. It's called Getting Past No, How to Deal with Difficult People. Well, I went through that damn book, and mostly it was about a kind of guy that was difficult, but wasn't the kind of guy Rick was. So it wasn't clear it was really there. And so Gordon and I got together, and I started talking. He started talking. Of course, Gordon interrupted me. Then Gordon interrupted himself. And we got in a fever pitch. At one point, Gordon says, we can't let him make this mistake. We owe it to him. So we said, okay, let's figure out what to do. So we each wrote a letter to him. And Gordon was particularly heavy-handed in his letter because he felt he could be, pointing out that if you work successfully in technology, you can do all kinds of crazy things like start computer history museums. Whether that was the line that actually made the difference or not, I'm not sure, but it was in there. Well, damn, we got Rick to reconsider. And that is, one of the single best hires I've ever made in my life for hiring somebody. It was one of the single best thing I ever did for Microsoft Research. As soon as Rick joins Microsoft Research, we all of a sudden have to get other people to join Microsoft Research. Now, I'd actually hired a speech recognition group into Microsoft Research before Microsoft Research existed. So we had a few folks already. I had a group called Advanced Development, and so we had a few people there. But we really needed to build a research team. And so we then embarked on a very similar sort of pilgrimage to a bunch of places that Gordon and I had done to say, well, who else can we recruit and how can we get them to come here? And some of those people said no, much to their later regret. But gradually we found people that we could convince to come. One of the principles that Rick and I developed early on in Microsoft Research is we wanted to hire people who, I used to say that they were narrowly insane. Meaning that they wanted to solve a really hard, ambitious problem. A problem that other people might think, that's kind of crazy, you couldn't solve it. But you wouldn't want them to be so risk-seeking that they were totally wacko. You just want them to think their problem was something they could make progress on. And one of the interesting things in managing research as a result, and something Rick became a master of, is, of course, one guy is working on his problem, and it's really hard, but he thinks he can solve it. This other person over here, she thinks she can solve her problem. Well, you ask them about each other's problems, and they go, oh shit, no, that's hard. Are you kidding? Oh my God. You know how many people have failed at that? The same person who knows in their heart that they can make their problem work is deeply skeptical about everybody else's. That's what I meant by narrowly insane. They have to be sensible enough that they can make progress and be generally sensible people, but they have to be just crazy enough to think they can do something no one on earth has ever done before. Microsoft Research is a huge collection of those people organized in a way that we could really make some progress. And my favorite hire in that whole era was actually Jim Kajia. Before Jim, we would have people come, and mostly there were people I knew or people that Rick knew that we would sort of heavily twist their arm and come, and we'd pitch for all we were worth and talk about the wonderful future, and it was going to be so fantastic. And it was this very intensive thing, and it was really future tense oriented, okay? We couldn't sell them on the present. We had to say, hey, we're going to build this great thing. Just imagine it. So Jim Kajia was on our list, but what Jim wanted to do was come and hang out for a week at Microsoft Research. And I said, shit, Rick, can we do that? I mean, do we have enough of a Microsoft Research? Isn't he going to see that the emperor has no clothes? I mean, God, we only have half a dozen people. Some of them are still unpacking their boxes. This is a disaster. And Rick said, no, I think it'll work. I said, shit. I said, then if it is a disaster, he's going to tell all these other people, I won't be able to go to SIGGRAPH again because people will all snicker when I come in the room, which frankly they were doing before that. But So, is this really going to work? And Rick says, yeah. He had some reservations. He says, well, we'll try it. So, Jim is there for the week, and he's scheduled to see me at like 3:30 on Friday. And I'm hearing from Rick and from Dan, who is also trying to manage the whole thing. They, oh, we think it's going okay. We think it's going okay. It's like, well, he seemed like this guy, but we're not sure. So Jim comes in to see me, and I said, well, how did it go? He says, well, I thought we'd just cut to the chase and try to convince you of the 5 reasons you ought to hire me. I thought, God damn, that is so excellent. I made it seem like he was trying to sell me a little bit. But in fact, we had gotten over the hump enough that a guy like Jim Kajia, who was at the top of his game, had this great position at Caltech, that he, after spending a week with us, he actually wanted to be there. That we were moving from an organization that was all about future tense into something where we had a little bit at least of present tense. So that was a terrific moment. As we started to build Microsoft Research up to the point that we got research publications. I remember the first year that we really had a big showing at SIGGRAPH, and we had gone from like nothing to about 25% of the conference. And then as other key conferences came up, suddenly we had people who were there, and there was this amazing sense that it was going to work. So as Microsoft Research progressed and grew, we got more adventuresome with the things that we would research. Initially we were focused on things that were really part of the core software mission that we thought Microsoft was about, but over time we said, we could afford to spend some time on things that are a little bit more theoretical, a little bit more out there. Well, in the early 80s, I was a graduate student at Princeton in theoretical physics. And one thing about theoretical physics in general, but particularly then, is there weren't a lot of girls in the class. But there were 2 in the class that I was there, and one was Jennifer Chase. Although Jennifer certainly attracted the notice of everyone in the department, it was only noticed from afar because Jennifer's husband was also in the class. And he was a punk. In every sense of the word, he was a punk. Actually, Jennifer was too. She would come to parties wearing a black dog collar with big, thick sharp metal spikes on it. So you were very intrigued with Jennifer, but you were also a little afraid, just flat out. So as we started looking at doing more mathematical and theoretically oriented computer science, I was at the time on the board of the Institute for Advanced Study, and Jennifer was visiting there. So Jennifer and I talked. We talked about her research. We talked about a variety of other things. I went to visit her at UCLA, where she also was, then again at the Institute. I said, hey, Jennifer, maybe you should come to Microsoft. And of course, this was as crazy to ask someone who was at the time thought of herself as more of a mathematician, really. It was as crazy to think about that as it was to hire the original researchers into Microsoft in the first place. But I persevered, and I got her to come out there. And she got intrigued. And she says, but there's a problem. My husband. And she said, I've got this husband, but he lives in Germany. I said, really? How does that work? She said, well, not very well. And of course, while she's describing Christian to me initially, I'm thinking, yeah, she sure can pick him. Let's see what this one's like. But in fact, we managed to hire both Jennifer and Christian to Microsoft. And they then went and hired a whole bunch of other people. And we managed to make Microsoft Research an institution that was not just great at pounding out code. Not that there's anything wrong with that. And not just great about things that are fairly applied aspects of computer science. Making a better operating system or a better file system. It's pretty easy to see how that directly would benefit a customer. So even if it's research that has a pretty short path to application. Not so with all aspects of abstract computer science and discrete mathematics, but in fact many of those ideas, even though they're more remote, they're also more powerful. And so they've become a part of the whole Microsoft research portfolio. Because Rick really was this great combination of somebody who understood computer science at any level of abstraction that you could imagine. But he also really liked computers, and he really liked to code. And he also, strangely, and this is one thing that was quite different. I like computers. I like to code, too. Rick likes people better than I like people. And so we'd have a frustrating personnel situation or another, and Rick would always have a way of dealing with it. And he'd have these great set of stories. We had a big issue once with these people that were bickering, and so he told us the story of the imaginary nickel. His kids were fighting in the back of the car, and he said, you know, you kids are squabbling so much. If I told you I gave one of you an imaginary nickel, you'd fight over it. Whereupon, this is exactly what they did. Well, that story was really useful in getting these two bickering, pretty high-level people at Microsoft to maybe consider they should stop bickering. And there was something that was more at stake than maybe an imaginary nickel. Another one of the favorite stories that Rick would pull out when we were talking to people about the pace of technology is he'd tell the story of one of his sons that would ask him to tell a story before bedtime, just pretty much as a way of delaying bedtime, as kids are wont to do. And then he'd ask a question. So he'd say, yeah, well, here's a question, or here's a question. So one night he tucked him in, and he said, Dad, when you were my age, did they only have 8-bit computers? And of course, Rick has to explain, actually, he was in college before he ever saw an 8-bit computer. An 8-bit computer was a hell of a thing. But to a child growing up then, 32 bits was normal. So no matter how antediluvian, no matter how ancient Dad was, he couldn't have been before the 8-bit era, right? But of course, he was. So over the years, Rick has been an incredible friend. He's been an incredible researcher. He's built Microsoft Research into one of the great institutions in the world. And besides all of the value that's given to Microsoft customers, Microsoft shareholders, that's very substantial. Research has made an incredible contribution because the ideas in research have changed the lives of millions of people. That was one of the lines, actually, I used on Rick to try to recruit him. It didn't work, but the line went like this. If you want to affect the lives of millions of people, Microsoft is the best place to do it, because if we have great ideas there, we can get them more clearly, more directly into products. Well, it didn't work, but then Rick came and he made the whole thing true, so he actually did affect the lives of millions and millions of people. So it's been an incredible experiment. This memo I wrote in 1991 sort of laid out all of the things that research was going to do, and almost every one of them we did in sort of the highest level sense. It says we'll open up one in Asia within 10 years. Well, we did that. It says we'll open up one in Europe. Well, we did that. It said we considered other parts of the world. Of course, we did. I say we. After I left, India and a variety of other places, even places like California, were added, just to show how far we would go in outreach. So Rick has, I just can't imagine a better research executive than Rick Rashid.
All right, so that was Nathan. Jennifer and Christian, I hope you'll forgive me for leaving in that anecdote. It was tempting to edit it out. No, actually, I really wanted to leave it in. So now we have Linda.
One day, I'll tell all of you what Nathan used to I'll tell the rest of the Jennifer recruiting story.
All right, do you have a mic yet, Linda?
No.
Let me get you a mic.
All right.
Here's one you can put on. All right, so Linda Stone is a writer, speaker, and consultant focused on trends and their strategic and consumer implications. In 1993, Nathan recruited Linda Stone to Microsoft after she'd spent 7 years at Apple. While at Microsoft, Linda worked for Nathan, Rick, and Steve Ballmer. And she has a few remarks.
Is that kind of like the Father, the Son, and the Holy Ghost and Who's Who? I mean, scary, right? Perfect that I'm following Nathan here. I really think one of Nathan's very best decisions was to hire Rick, and Nathan didn't exactly tell the entire story of recruiting Rick. I don't know if any of you remember the whole Charles Simone love bombing aspect of recruiting. No, you don't. Okay. Well, I think Nathan is probably busy patenting that process if he hasn't already. But there was really there was a lot that went on in that particular recruit. So I started getting to know Rick when we went to the Cambridge lab together, and I was along on a lot of meetings with Nathan, and Rick was assigned to do a lot of Nathan follow-up, which included hours on the phone all night long with people like Michael Friedman, who Jennifer Chase had decided Microsoft really needed to hire, and then Rick got very involved in that process. And I was meanwhile with Nathan. I was mentioning this to Rick at lunch at places like British Telecom, where Nathan and the CTO there were talking about world domination and could it be shared or whatever. Anyway, so as Nathan was preparing to move into the CTO role, he at one point he said, he didn't mention to me that he was, that things were shifting, but he said, could you imagine working for, and he named a particular executive, and without thinking, just totally uncensored, I looked at him and I said, I can't work for him, he doesn't read fiction. And you can imagine Nathan looked at me and said, that's the most ridiculous thing I've ever heard. You guys have heard him say things like that before. What do you mean? And I only read 1 or 2 fiction books a year anyway. And I looked at Nathan and I said, it's kind of about suspending disbelief, especially in research or with creative people. If someone only reads the Wall Street Journal, how dimensional is that? And so Nathan, when he did tell me that he was going to take a different position and that I'd be shifting to work for Rick, he said, Linda, you're going to be fine. I know this because Rick was an English major. And maybe that's Rick's secret, that he was an English major. And along with his incredible technical background, it makes for a really extraordinary combination. Rick is very capable of suspending disbelief. He's, as Nathan remarked, amused by almost everything. In fact, more often amused than stressed. He doesn't take himself or any of the rest of us too seriously. Isn't that a nice thing? Lots and lots of wisdom and adventurous spirit. And Rick, I think we've all been very, very lucky to know you and work with you over the years. Thanks.
All right, thank you, Linda. So next up we have Eric. And while Eric is making his way down, I'll introduce him. So Eric Horvitz is a distinguished scientist and deputy managing director of the MSR Redmond Lab. Eric joined MSR in 1993, along with his colleagues Jack Brees and David Heckerman. Yeah, you can pick...
I think it's number 4, right? You picked that? Here we go.
We're on number 4 now.
Here we go. All right, thanks. Am I on my mic here?
And just stick that
All
on.
right, great.
Good to go.
Thanks. Thanks, Rich. In preparing to make some comments, I was actually reading up on operating systems the last couple of weeks, and I found the learnings very interesting. And I actually had a chance to talk to Rick about some of the principles and his thoughts and reflections in working on Accent and later Mach. And he mentioned to me that he has come to know himself over the years as someone who tends to find similarities in things rather than differences, and that this leads him to simplify complexity into parsimonious sets of principles. And in looking at the work on Accent and Mach, you see quite a beauty there. In fact, I really enjoyed looking at this idea, this kind of core concept of decoupling mechanism from specifications of policy, which hadn't been done very much earlier. that was a kind of a trend also in machine intelligence, to separate out knowledge bases or domain-specific knowledge from the pure parsimonious inference engines that could be reused in a number of places. Right around the time that Mach was blossoming into the open world, we heard from Avi earlier, as a platform that would catalyze a great deal of innovation, Rick shifted his focus from operating systems to formulating the operating principles of a research laboratory in computer science and executing on a dream of a fundamental computer science laboratory, and formulated some simple and parsimonious sets of principles. Some are very explicit, and Rick talks about them all the time, and some are quite implicit, but they're still principles as to the way this organization works. And he's not wavered on these principles since the inception of MSR in any way that I can tell. Moving from Accident and Mach to my first encounter, along with, as you heard earlier, with Jack Breeze and David Herkiman in July of 1982, when we received a strange request, I think through David, because David was high school friends with Nathan Mervold, to maybe we want to come up and talk about the things our startup was doing at a Stanford-era grad school startup working on Bayesian inference. We were going to change the world. We were excited about that. Here's a screen capture. Thank David for getting this video off the, whatever you got it off of. But the screen capture of Rick introducing me as a speaker. Rick was a young man there, and I was so excited about Bayes' theorem, and I was talking how wonderful that would be for the future. And then there's David, Jack, and I reflecting, about answering questions, Q&A after our talk. But we actually had no idea what on earth Microsoft wanted with us. It was a Microsoft research team. We said, this is not really, a few people here, and they're all very nice and very exciting, and they have exciting ideas, but David, Jack, and I are the people you heard about from Nathan just now, early, intense arm-twisting era, and of people whom he knew. In this case, he had known David. And boy, I just heard for the first time about that book that Nathan read. Now I'm getting a better idea of what was going on. It's like Jack and David understand that, because Nathan would not give up. We were just not interested in coming up to Microsoft. But if anything, this strange place to the north of cool, hip, California Avenue or startup and Stanford and so on. If anything moved us really deeply, it was the principles we heard from Nathan and more so from Rick about the idea of enabling some sort of a platform for long-term research. And Rick made it very clear from the beginning that again, we were in disbelief, that the primary mission of the organization would be to expand the state of the art in the areas that we do research in at MSR, across the breadth of computing. And at the time, it didn't seem like an obvious thing for Microsoft to be doing. But it turns out that this unwavering commitment to fundamental computer science makes a great deal of sense in terms of the transfer of new ideas to such a large-scale operation as Microsoft, with such a broad array of technologies and products. And I've come to really believe this and see how this works in terms of pursuing the fundamental ideas. Fundamental computer science is the way to get to all sorts of applications, new kinds of products and directions, new ideas about services. And I've had this debate with people in this room who are visiting today from other places, that this is not a crazy idea. They try to convince me otherwise, even today. So that's a big, important goal here and mission. I remember this really smacked me in the face when I actually had my first review in Rick's office, my first annual review, and I sat with him, and I was so excited. We had come up, even though he had done some nice theoretical work, dissertations. When it came to our startup, we were really gung-ho about getting stuff into the real world. And we were so stoked and excited about stuff we were doing, Office and Windows, and I was just chatting up a storm with Rick about how wonderful the engagements had been with the product teams. And Rick just listened and smiled and thought this was all very nice and so on. But then said, after a pause, are you sure you want to get the product teams so used to this kind of service, these features, and I mean, we want to maybe think broader long term. I mean, you might want to pull back a bit. I thought, wow, he's walking the talk. This is let's really push on. He's not impressed by the stuff that we thought would blow away somebody maybe in an applied computer science lab, the actual engagements we were having. So it really underscored that for me. Now you see here it says, in the areas that we do research, and you say, well, wait a second, who decides about what we do? And I guess Rick just mentioned on Monday, or Tuesday, it was a public day at TechFest, he's asked all the time, well, how do you decide what areas to pursue? And I actually listened to a video of Rick this on Monday, and he said that here's how he answers this question. I don't invest in specific research projects. I don't invest in specific areas. I invest in people. We try and hire the best and brightest people wherever we can find them, because that's what really drives long-term research. That's what drives the innovation and breakthroughs. So these comments reflect another of Rick's elegant organizing principles of the operating rules of a laboratory. Identify great people, show them great trust, give them great independence, and get out of their way. So as in Mach, policy would be separated and in fact largely removed from the mechanism of MSR. So the research directions will be defined by researchers themselves. More generally, people throughout the organization will be treated like adults with respect and empowered to make all decisions. And this kind of distribution of responsibility plays a central role in MSR's personality in all of our labs today. Such freedom of decision-making cuts down to the core freedom in academic scholarship of publishing decisions. People are often surprised that there are absolutely no controls on publications at Microsoft Research. There's no tower of lawyers. Researchers don't ask their research managers, can I publish this or that? This has been not only a fabulous reflection of the way we work, but it's been an incredible recruiting tool to hire the best and the brightest. Because people seek, the best intellects in our field seek that kind of academic freedom while being in a place where the fulcrum is at the horizon and the lever can move the world. So let me just mention a third unstated principle that others have mentioned in passing. I think it's a core operating principle of Microsoft Research, and this is on positivity, optimism, playfulness, and humor. We don't see that in our slides when we say, what do we do at what is MSR about? But it's critical. The importance of humor, lightheartedness, and whimsy really cannot be understated or underestimated in an organization like Microsoft Research for its health, its well-being, its productivity. I'd long been actually impressed with the words of John Adams. If you look at his reflection about the Commonwealth, he wrote the Constitution of the Commonwealth of Massachusetts. He actually mentions that the importance of honesty, sincerity, and good humor among people in building a nation. And beyond the importance in the design of societies and nations, a number of studies by psychologists have found that having fun, being in good spirits, laughing, enhances creative invention, connections, and discovery. So at Microsoft Research, the standards of playfulness and lightheartedness come right from the top. I've always been thrilled by what it's like to walk into Rick's office. Let me do a simulation if you haven't been there yet. I mean, Rick has the best collection of Star Trek stuff. You can imagine he has a signed picture sitting with James Doohan, Scotty, who used to live in Redmond, and thank God he made a connection with Rick before beaming out. And you can go to the first Halloween parties I went to at Microsoft. There was Rick in full regalia as Captain Picard. beaming down for a brief visit with his crew. His humor and spirit of lightheartedness is always on hand and permeates the organization. I have to say that we just had a recent, about maybe 2 or 3, Rick will remember this very clearly, about 4 or 5 months ago it was, we had a researcher and a product team person who had a difference of opinion about how they would engage, and both sides wanted Rick to come up with a policy. Microsoft Research to say something about this, with different opinions, of course. And I sat in on the meeting, and Rick was deliberating and reflecting a bit about this. Rick said, I could intervene, I can help you out here, but why don't you make the decision yourself? This is really up to you. And but after there was agreement that would happen, Rick said the great words, "With great power comes great responsibility." I was sitting there thinking, okay, this must be FDR, or is it John F. Kennedy? And then with a smile, Rick said by Spider-Man. Actually, I checked into this. It was Uncle Ben who mentioned this originally to Spider-Man. So I'll just say, before finishing up here, that on the lightheartedness front, I would love walking past Rick's office. I don't know what happened to this poster, but this poster was outside Rick's office for at least a couple of years. And it's just kind of interesting to basically think about the rules here that comes from this poster. All I need to know about in life I learned from Star Trek. I love this poster. It contained important things I'm sure Rick agrees with, like non-interference is the best policy, keep your phaser set on stun, and don't put all your ranking officers in one ship. However, no doubt he agreed most deeply with the main charter, one that resonates with the mission, his mission and the mission of Microsoft Research, which is to boldly go where no man has gone before. And on the special occasion, I and my colleagues would like to say to Rick and to MSR, may you live long and prosper. We'll stop there.
All right. Thanks, Eric. That was wonderful. All right. So next we have Jim Laris. And Jim, you should be up there somewhere. So while Jim is coming down, let me introduce him. Jim Laris is a principal researcher at MSR. He recently returned to the Redmond Lab after 4 years in the Extreme Computing Group as their Director of Research and Strategy. Jim joined MSR in 1998 from the University of Wisconsin, where he was an associate professor.
Which one of these mini cables?
And you can use the PC4 setup there. And then there's a countdown timer over there.
Oh no. Let's try that again. Don't push the sleep button when you mean to project. Always good advice. So, and just to provide a counterpoint to all the discussions of operating systems this morning, I thought I would talk about one of the other really big groups and research areas at Microsoft Research, which has been software tools and software engineering. And this is prepared with help of a number of other people, Bob Davidson, Yuri Gurevich, and Wolfram Schulte. It's actually very significant. I think when I put up some of the efforts, you'll see sort of a large amount of impact this has had on both Microsoft and the research community as a whole. One of the most interesting things is that in this area, our customers are Microsoft, not Microsoft's customers. And so unlike a lot of the parts of the company, we're actually dealing with the people who are using the results of the research directly on Microsoft's products, as opposed to doing it through the intermediary of the product group. And I think one of the real values of this work is that it demonstrated to the company the value of having a research lab, particularly at various points inside Microsoft's history where we had a great deal of trouble trying to get Windows 2K shipped, dealing with the security problems in the early 2000s. MSR was there with a lot of useful technology, things that would not have been very hard for the rest of the company to devise on its own. A lot of times, you met people a while ago, it's not so much true anymore, you said you were from Microsoft and they heard PPRC, not Microsoft. because they would produce the tools that a good number of the developers inside the company were very familiar with. And they said MSR, but the words were PPRC. And I also point out that it wasn't just an internal effort. The research agenda in the fields that I came from, programming languages and formal methods, was pretty well set by the research that was done in MSR. We did some pioneering work on fixing device drivers. The community is still working on fixing device drivers. I just came from ASPLOS this week. One of the high-ranked papers there was a survey of the Linux device drivers, all 2,000, whatever of them, looking at them in terms of categories and so forth. And the large community of people are still very much following in the footsteps of work that was done here originally. Just go back, look at some of the early histories. Some of the early groups inside MSR, and I wasn't here, so I can't really put them in proper chronological order, was the ADT group with Bob Davidson, who's still sitting in the back there. Their tool, BBT, which was called Lego in the early days, improved Windows paging performance by basically taking all the code that you never use, like error handling, and putting it out of line. Interestingly, it was done so you could run on very small machines, 4 to 8 megabytes, almost unimaginably small machines. That problem is still here. The problem now is that you've got to do this on your 4 to 8 megabyte L3 caches, and you still have the same problem as you had before. It's just never gone away. It's just migrated to a different level of the memory hierarchy. Charles Simoni had the IP group, which was looking at improving programming, basically in the idea that you would want a domain-specific language. That idea is still very current. There's a great deal of work on domain-specific programming languages these days. In fact, it's one of the hot topics in several different fields. This basically sort of says that when Rick was here and setting up Microsoft Research, he was picking the right problems. These were deep, hard problems that we were trying to tackle in those days. Daniel Wise set up the SBT group, which was the precursor to the group that I set up. The work they did on scalable program analysis and the AST toolkit was really essential to Microsoft in the early 2000s when the security problems came, because AST toolkit was the precursor to Prefast, which was the tool that we used to find a lot of the buffer overruns in our code. Longer-term efforts. I joined Microsoft Research actually in '97. I came for a year on sabbatical, and I should talk about Rick's recruiting methods since everybody seems to have a story. So we were in Building 9, and I had an office there. I think I had an office with an intern at the time, and several times a week, Rick would show up in the afternoon in the office and just sort of sit down and start talking to me. And I thought, this is nice. He's got a lot of time on his hands to talk to me. And, he had this very interesting recruiting strategy, which I've never tried on anybody, but it might work. I was, came from the university. I'd used Unix all my professional career. And so I was trying to figure out this Windows and Visual Studio, and so I had a large pile of programming manuals on my desk. And Rick would come in and say, I never used those. I've never looked at one of those programming manuals. I'm writing, thousands and thousands of lines of code, but I don't even need any of that stuff. And I'm like thinking, really? How could he do that? He must know this stuff a lot better than I do. And he just sort of, intrigued me that there was really something there to this Windows thing at the time, which wasn't quite clear to me with my exposure to it. And so, that and the combination of sort of the research lab made it very appealing to switch directions. I hadn't been doing software tools. I looked around Microsoft and saw this great opportunity. I set up the SBT group and started trying to answer the hard question, as one of the previous speakers said, why were the developers at the world's largest software company using exactly the same tools as undergraduates or graduate students at a university who were using free tools at the time. We did a lot of work on scalable program analysis, a whole new software analysis technique called counterexample-driven refinement. And then I think another really significant thing, we started looking at the human interactions of programming, which was something that was very different from the technical analysis of software, but extremely important to really understand what the root causes of the problems were. At roughly the same time, Yuri joined MSR and set up the Foundations of Software Engineering, which was a much more theoretical view of software engineering, and actually very nicely complemented the tools group that I was running. And Wolfram joined very early on and then took over leadership of it. And their work on executable specification and model-based testing actually paid off about a decade later when we got in a lot of trouble with the EU and had to document and specify the Windows interfaces very carefully. And this provided the technology that satisfied a lot of Europeans and saved Microsoft a great deal of trouble. And obviously, around the same time, we set up an internal tools group, PPRC, under Amitabh, which produced a very large number of tools that were pretty universally used inside Microsoft for doing software development. In fact, many of them still are used inside Microsoft. The combination of these groups really were crucial at various points inside Microsoft's early history. Getting over the hump of shipping Windows 2000, dealing with the security problems that came up, helping to get Vista out the door and solving some of the really hard problems there. And I think it's a real testimony to Rick and the other people who set up Microsoft Research is that they were willing to invest in what is, I think, an endless quest to eliminate bugs in software, and that they picked people who picked the right problems, and these problems actually really did pay off for the company as a whole. Thank you.
All right, great. Thanks, Jim. All right, so next we've got Ed Lazowska. Ed already has his mic, and looks like you're speaking without PowerPoint, which is great. So Ed Lazowska holds the Bill and Melinda Gates Chair in Computer Science and Engineering at the University of Washington, so they must be very important. Ed is actually a founding member of MSR's Technical Advisory Board. I think offhand you must be the only member to actually stay on the advisory board through its whole tenure.
Raj was there in the beginning, but
yeah. So he's back now, but was back for a while. But anyway, so it's still you're still going strong, Ed.
And I feel like I'm in the control booth of the Starship Enterprise here. It's unbelievably great. So, one of the great privileges of my professional life has been my involvement with MSR since the beginning, sort of before the beginning. Nathan came to talk to me. I hope it wasn't to reject me as as the leader of this thing. And, it was said that he had this loony idea. He was going to hire some guy who was going to create a world-class fundamental research organization at Microsoft. And this is a typical Nathan-esque, audacious idea, and invited me to sort of act as an advisor on that. And I leapt at the chance. And Gordon was involved at that time, and it really has been a remarkable now 21 years, I guess. And the changes are astonishing. So within a year, Nathan had recruited Rick. One of the problems as you go later in the afternoon is other people have already said all of your comments. But this effort included recruiting Rick's kids. I'm sure you remember this. I remember Nathan was on the board of the Woodland Park Zoo, and he would go and procure enormous boxes full of zoo paraphernalia and mail them to Rick's kids in Pittsburgh. I think when you're being recruited by Nathan, when he decides that you're the one, you'd better be prepared for the full court press, not just on you, but on the entire family. Anyway, the rest is history, right? In its 20th year, Microsoft Research is clearly the strongest computing research organization in the world, and it's the house that Rick built. We heard about the recruiting of Jim Kajia a bit from Nathan. There's a part of that story that Nathan didn't tell. I remember that Nathan invited a bunch of us over to dinner at his house, and he had recently acquired a barbecue rig that was about the size of a city bus. And Nathan spent the entire day stoking the fire and barbecuing stuff, all in aid of showing Kajia a good time. So this is typical of what Nathan did and the sort of recruiting skills that Rick inherited. Anyway, I'm not really going to talk about the history. I want to talk about the role that Microsoft Research has played in strengthening academia and Rick's role in making sure that that happened. And I'll give you a couple of examples. Eric Horvitz talked about the fact that, of course, all the publication from MSR is open. And I don't imagine that was a foregone conclusion. I figure that was a principle that Rick laid down early on. And it's important to understand that Microsoft's financial investment in Microsoft research on an annual basis is about what the National Science Foundation spends on computing research. Right? So, it's a significant amount of money. It makes an enormous difference to the worldwide progress of the field. And the fact that essentially none of this work is proprietary, that almost all of it is published in the open literature, and that MSR researchers, all 800 and some of them, are part of the international computing research community is just an extraordinary contribution. So MSR drives Microsoft forward, but it drives the field forward as well. And the way I tell this story is if you go back 30, 35 years, the computer science GDP in the country was a whole lot smaller. And there were three big wedges, AT&T and Xerox and IBM, each had major fundamental research organizations. And today, that GDP pie of the industry is far, far bigger. But of all those new companies, to first approximation, only Microsoft is making a serious investment in work that goes out beyond one product cycle. And that's a remarkable contribution. When Nathan and Rick started this, right, in 1991, Microsoft had just crossed $1 billion in annual revenue and had 5,000 employees. So Microsoft was not at the time in a position where it could necessarily afford an investment on that scale. Right? So it was just an incredibly gutsy thing to do, to realize that Microsoft was approaching the forefront of the industry despite its relatively small size, and that meant that in order to grow, it had to move the forefront forward. Right? So just a remarkable commitment. So Microsoft contributes hugely to the field, Microsoft Research, and I could talk about all the little things which are really quite big, the PhD fellowship program, the faculty fellowship program, the graduate women's program, the Connect SDK, internship programs, research grants, support of the National Center for Women in Information Technology. It goes on and on, but what I want to do is focus on Rick's particular effort and MSR's effort to build the strength of universities directly. And I'm just going to give you two examples, and then I'll be done. The first is mine from the University of Washington. When Rick first arrived here, we had a discussion about the University of Washington's computer science program. We were a lot smaller then and a lot more fragile, and Rick made a commitment that he would not recruit faculty from the University of Washington. And that's a commitment that he has scrupulously adhered to. And it's extremely admirable. We're a lot stronger now. We could afford to lose some people, but in 1991 that wasn't the case. And Rick realized and was just emphatic that having a strong program in Seattle, a strong academic program, was important to the region and important to MSR. So, there are lots of people in MSR from lots of university former faculty members. Jim is a great example, and Rick has just stuck to his commitment in the beginning. Not only not to recruit from the University of Washington, but to do many, many things to make it a stronger program. And it's paid off enormously for us. Microsoft and Microsoft Research are by far our single biggest strategic advantage. And together, we're really doing a lot to make the region a stronger center for technology. When I moved here in 1977, technology here was Boeing and some electronics manufacturers. And of course, the landscape has changed totally in that time, largely thanks to Microsoft, and in computer science, also thanks to Microsoft Research. I want to mention one example to reinforce this. In the late 1990s, Microsoft purchased a startup company done by David Salison, a faculty member of ours, and they purchased David along with that startup company. So that's the one migration of a UW faculty member to Microsoft Research. But Rick immediately turned around and granted half of David's time back to us. All right? And that relationship paid off years later in collaborations with Rick Zaleski that led to things like photosynth. So, it's just amazing for us. This same sort of what I'll call enlightened integrity was really evident in the approach that Microsoft took in Asia. When MSR Asia was established in 1998, the Chinese university system was still in recovery. And you can imagine that there are three approaches that Microsoft could take. One is to extract the few really top computer scientists from Chinese universities to stock the lab. Another was to stock the lab with expats and wait for the Chinese university system to improve. And the third was to take aggressive steps to improve the Chinese university system. And what MSR Asia did, as I think most of you know, is institute this program for what were called, I think, associate researchers. And these were essentially postdocs some of the best graduates of the Chinese university system who would be brought into MSRA for a period of a few years, and then by and large return to the Chinese university system to make their programs stronger. And so I think Microsoft Research Asia, again under Rick's leadership, deserves an enormous amount of credit for the upsurge in the computer science graduate programs at Chinese universities. So it's a clear, active contribution to strengthening those programs, recognizing in the long term that benefits the nation and the world and Microsoft as well. So the bottom line is Rick has his head screwed on right. And we've all been beneficiaries of that. Those of us in Seattle, those of us at Microsoft, all of you, really the national and global computing research community. So Rick, thank you very much for having your head screwed on right.
Thanks, Ed. So now we have Peter. Here he comes. Oh, we need to get your microphone back. I'll just put this one on.
This is the right one?
Yeah. So Peter Lee is Corporate Vice President of Microsoft Research Redmond. He started at MSR in 2010. So maybe the most recent hire you're going to hear from today, actually. After many years at Carnegie Mellon and a short stint at DARPA.
Great, thanks. So it's really fun to hear all of these old stories. I started in 1987 at Carnegie Mellon, finished my PhD at Michigan, and then was hired at Carnegie Mellon, and that's when I first met Rick. I don't remember my job interview with Rick. I remember distinctively my job interview with Satya. I also remember the most memorable job interview was with Alfred Spector, because after some questions of a technical nature, Alfred, finding out that I was still single, told me about the landscape for single people in Pittsburgh. And so I was very, I didn't know quite how to take that. I didn't know if that was a good sign for my interview or a bad sign, but it was good. But of course, it didn't take long to become of course, very, very familiar with what was going on there, and you know, it was an amazing place at that time. You literally felt like you were coming into a place and living in the future. I remember vividly sitting down, and the first computer I got was this strange workstation running this strange thing called Mach, which at that time I think was only sort of half working. I was trying to do things with this language called Scheme. It was really pounding on the virtual memory subsystem, which somehow, as far as I could tell, wasn't really working at the time. And we were running on these strange file systems, this thing called AFS. And it was all of this kind of semi-homebrewed, stitched together research software, but we were dog fooding it. In fact, it was the first real experience with dog food there. So very, very exciting. Like Jim Laris, I wanted to provide some counterbalance to all of this systems stuff. And in that era, in '87, explain a little bit about how my research career started and then how it was fundamentally influenced. In fact, I would say that the direction that my research career and the successes I've had in research, I think would not have happened had I not had the contact with the systems work that that Rick really played such a big role in at CMU. So let me try to paint that a little bit of a picture. And I also thought, well, in light of all these other talks, I was going to talk about tech transfer and a management talk, and that's the subject of my written contribution to the FestSchrift. But I thought, you guys all need to be subjected to some math here, and so I'm going to show you some math. All right. So, and all of this is a little, if you're an expert, I'm peppering this with a few white lies here and there. But let me say that when I started at Carnegie Mellon in '87, I was doing fairly theoretical work in applied logic and formal semantics. And to just sketch out a very simple logical system, what you see here are what are referred to as inference rules. So if you have propositions, a proposition is a statement that can be true or false. So let's just call those A, B, C, and so on. And then each one of these things for the horizontal line is a different rule. where you have kind of the preconditions above the horizontal line and then what you can conclude underneath the horizontal line. So in the upper left, you have the simple rule. If you know that A is true and you know that B is true, then you know that the logical proposition A and B is true. So it's a very simple kind of rule. In the middle, top, if you know that the statement A and B is true, then you know that A is true, and so on. In the lower left, that's a little more complicated one. In the square brackets, that means let's just imagine that A is true. And if you imagine that A is true, and from that you're able to derive that B is true, then you know that A implies B, and so on. Okay, so logicians and the kind of work that I was doing as a PhD student and then as an early faculty member at Carnegie Mellon was this style of work. Now, what I was actually working on is in a domain that part of which was called formal logic, and the word formal really for a systems person would mean, can we write a ASCII-friendly language for writing down math? Okay, and that's what's meant by formal logic, and you can. And so we'll make a syntax. And so if we have a proposition, logical statement, A, and if we have a proof of that statement, P, then we'll write in ASCII P:(A). The colon means P is a proof of A. And so with that, we can rewrite all of those rules that we had before. So let's look at the upper left inference rule. If we have a proof P that A is true, and we also have a proof Q that B is true, then underneath the horizontal line, we know that A and B is true. And you know that for and, I'm going to use an asterisk, just to be ASCII friendly. And furthermore, we can have a syntax for what does that proof look like. And so the syntax for that proof is open parenthesis, write down the first proof for A, put a comma, then write down the second proof for B, and then close parenthesis. And that's the utterance of the proof of A and B. And then all these other inference rules go the same way. All right, so now we can do all of our proof writing on a teletype machine. And so let's do some math. So suppose we want to prove the little tautology that A and B implies B and A. And so what do? Well, let's assume that we have a proof that A and B is true. We'll call that proof X. Well, then we know that we have a proof that A is true. And so the way we write that proof is FST of X. We also have a proof that B is true. And so we write that proof SND of X, according to those inference rules I showed on the previous slide. That means that if we write down the proof open parenthesis, SND of X, comma, FST of X, close parenthesis, that is a proof of B and A. And since we started with this assumption of the proof X, then we have the full proof of A and B implies B and A, and I've written it here. All right? So it's a strange way to do math, but what's wonderful about this, and what I found incredibly and in fact beautifully painful about this, is that is a piece of code. In fact, that's a piece of code in a programming language called, in this case, ML, although it's the same type system as the Microsoft programming language F#. And so proofs, when written this way, are programs. You can actually execute them. But most importantly, for a mathematician like me, checking whether a proof is correct is simply type checking. Just your garden variety ordinary type checker that you find in your compiler can be used to do type checking. And furthermore, you can have a smart blackboard that just by using a type checker, every time you write the next step of your proof, you can't go wrong. The type checker will tell you if the next step in your proof is wrong. And at Carnegie Mellon at the time, there were luminaries such as Dana Scott and John Reynolds and so on who had really laid out this field, and I was completely sucked into this, and that's why I joined the faculty. In fact, I think this is so beautiful that this must be the right way to think about software. If it isn't, it's the cruelest hoax by God that you could ever imagine, and so it's got to be the right way. And in fact, the Microsoft F# language, which has its origins in Microsoft Research, concludes the same way and is based on the same design principles. All right, so what does this have to do with Rick? Well, so I came to Carnegie Mellon, and I was kind of across the hall from H.D. Kung and next to Satya on one side and Eric Cooper on the other, and Rick was just a little bit around the corner down the hall, and I would get questions about what is this stuff good for anyway, and I would learn something about microkernels and the kind of beautiful modularity in operating system design that would be afforded by this, portability and modularity advantages. So all of that was really beautiful. And the design was interesting to me because it created value for mechanisms for software safety and security. In other words, the microkernel design would make or show some greater advantages if there were ways to safely inject code, for example, into the kernel in ways that would provide certain safety guarantees. And that idea completely changed the direction of my research, because I realized at that point that these proofs, these types that were proofs of the properties of programs in the context of a microkernel operating system design could actually have significant practical value. And in the mid-1990s, early to mid-1990s, I changed the direction of my work to focus on that. And that led to a long series of collaborations with Brian Milnes, who then went off to join this startup called Amazon. Then Doug Orr, who double dated with me and was the best man at my wedding, is now running a big part of Google Seattle. And then Brian Bershad, who was running one of the operations here also. And then Steve Luco, who is in the Internet Explorer team, Dave Tarditi, who's in the Midori team here at Microsoft, and all of these really directed towards developing techniques to allow you to attach certificates or provide other inherent guarantees in code to have much, much lighter weight and more modular operating systems. And so the conclusion is, if you get too close to Rick, you end up coming to Seattle and ruling some part of the world here. All right, so let me just wrap up here. For me, that direction of research made my research career. And I don't believe it would have happened anywhere else. In any other context, I would not have gotten to where it has been. And in fact, the highest accolades have not been in the theoretical community, but in the operating system community, such as with the SIGOPS Hall of Fame Award. And at Microsoft Research, and this is something I think that Jim Laris really emphasized, it hasn't been just about systems research. It's been in everything from graphics and AI, machine learning, as well as software development and security. And in fact, some of the most important practical outcomes have been in the area of software development. So let me conclude there and just say, Rick, thank you. If I look back on it, man, I was lucky to have run into your ideas. I don't know where I would be today without it. So, great.
Thanks, Peter. All right, so next we have XD. So XD is the chief architect in Microsoft's Online Services division. Also has the title of Distinguished Engineer there. He joined Microsoft Research in 1993. Prior to that, he was on the faculty of Carnegie Mellon, where he worked with Raj Reddy and others on speech recognition.
There are multiple clocks here.
Yeah,
Which one should I use?
You can use the PC4.
This one, PC4?
So that's the correct one, yeah.
All right. So not projecting. All right. Okay.
And if
is
you
microphone on?
want to use the clicker, then you need to plug in the USB cable. And the countdown timer is over there.
Okay. Thank you. I think it's going to be very hard for me to speak after Peter, because he is the guy running research. I was kicked out many years ago by Rick Rashid, but I will try anyway. I joined Microsoft Research in '93. Rick had this wonderful contribution to so many things. I'm not going to really to talk about that at all. But I just cannot resist to search Rick Rashid on Bing. His beautiful picture, just everything is there. I want to share some personal story of my 19 years at Microsoft. So I joined the research. That was 1993. Creating the team was the most important thing, Rick told me. So we went to the West and searched all the cowboys we could have, and we actually built the team. We had, we were well equipped. So that was the team we created in 93. It's just amazing. Many of them are still around today. I don't know if you can recognize some of them. And that's the test. Really, most of them are really playing a very important role because of Rick's help, because of the onboarding experience of Microsoft Research in the early days. The second thing I want to talk about is really the passion and the vision Rick had. And that had a profound personal impact on me and to so many friends around me. And I remember the vision we had for speech was to make speech mainstream. Rick really inspired all of us. We shipped the first speech API in 95. We were the first to bring speech to the public. And since then, we have been shipping speech from research. Since 2000, roughly 99, I don't remember the date, Microsoft decided to establish the sizable product on speech. And we actually, I had the privilege to leave research. We really got a lot of help from research. We even embedded the whole speech research group into the product. And that really was a great example of practicing Rick's philosophy. Now the tech transfer is full contact sports. So over the years, I have been in research and out of research. I always remember Rick's philosophy: take risks and look for art. And I was very impressed that the mission statement of MSR has not changed for all those years. One thing that I remember, actually, I want to talk about is really what we did. I just searched on Bing again. One of the things that really caught my eye was MyPad. If you actually just watch that out, MyPad, also what Apple is trying to do, because a Chinese company is shipping ePad. They're really blocking that company from using ePad. I think, when you talk about long-term research, you cannot talk about long-term research until you wait after 10 years or so. The MyPad, if you don't know what it is, that was the research we started, incubated, working with HTC in 2000. And Bill Gates showed this off in the CES in 2001. I remember what I talked about to the press in 2000. We want to sell this as a vision, not only to Microsoft, but to the whole industry. I have no idea if Steve Jobs watched that, and they just removed the M, and from that name, I have no idea, I cannot prove that. But that vision lived on because of the research we are doing. Another thing I really want to talk about is really, after I left the research, we have been working with a lot of great talents in MSR, thanks to Rick's leadership. We are really thinking about the next web interaction metaphor. Hypertext defined what web interaction is today. That's text-based. But moving forward, this hypertext-based one is really based on the touch, based on the entity, based on the contextual information. You can explore and browse, search beyond the search box. So we have innovated a lot of great technology. I think we have to wait for another year to talk about if the next generation web interaction is going to be hypertext-based or hypertext-based. So this is the picture I took when we celebrated our achievements. And I think the leadership is really what matters. That inspired all of us and helped all of us, supported all of us. Thank you, Rick.